Hey everyone, today we are going to solve the daily LeetCode challenge of 1st March 2024, and the problem statement is maximum odd binary number. So let us first understand the problem statement. So according to the problem statement, we have been given a binary string S. It means that it contains only zeros and ones, correct? And what we have to do is we have to rearrange these bits, that is we have to rearrange the 0 and 1s so as to give a resultant string that has a maximum odd binary value. Now what does it mean? It means that the resultant string which we get, its conversion to decimal value should give us the maximum odd value. So let us take an example. If we have 100 in its binary form, then its possible rearrangement would be 010 and 001. So the decimal conversion of 100 is nothing but 4, of 010 is 2, and of 001 is 1. Now what we have to do is we have to return the string that represents maximum odd value, right? So out of these three values, we have only one value which is odd, which is 1. And this particular string represents the maximum odd binary number. So this would be our answer, correct? Now coming back to the question, one more thing which we have to keep a note is how do we convert a binary string to its decimal form? It's by multiplying its ones place with 2 to the power 0. Similarly, by multiplying the element of this place with 2 to the power 1 and this place with 2 to the power 2, this place with 2 to the power 3, this place with 2 to the power 4, and so on, right? So one thing you must notice is that 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and so on. So one thing you must note is that in order to get a odd number, right? In order to get the odd number, we must have a 1 present at this ones place, correct? Why? Because you can see that all the values except this particular place, all the values, here it's 2, here it's 4, here it's 8, here it's 16. So as we move here, all the values would be even. Why? Because 2 to the power, if we have 2 to the power I, right? And if I is not equals to 0, then all the values would be even, right? Why? Because 2 to the power 1 is 2, which is even. 2 to the power 2 is 4, which is even. 2 to the power 3 is 8, which is even. Similarly, for any 2 to the power I such that I is not 0, then it would always be even, correct? So in order to get a odd number, we must have a 1 at this particular place. Why? Because let us assume that we don't have a 1 at this particular place. Then what will happen? It means that we have ones at somewhere here over all these places, right? Then these all numbers are what? These all numbers are nothing but even. So sum of any even number is what? Sum of any number of even number, it will always give us even, right? Irrespective of how many even numbers we are adding, sum of even number is always even. So in order to get an odd value, we must add an odd value to the even number, right? Because sum of even number and even number is always even. And in order to get an odd result, what we have to do, we must add an even number with odd number. So the bit present at this place must be 1 in order to get an odd number, correct? So now that we have understood that how to achieve an odd binary number, now let's see how we can achieve the maximum odd binary number. So as you can see that as we move towards the left, the value increases. Here it's 2, here it's 4, here it's 8, here it's 16, right? So the value increases as we move left. So if we will have almost all the ones except for 1 at the left side, then we will achieve the maximum number, right? Because all the values as we move left are the maximum values, right? They represent the max value. So in order to achieve maximum number, what we will do is we will place all the ones except 1 at the leftmost part. So what we have understood till now is place 1 at the end, right? Which is nothing but the ones place. That is, we should have 1 at the end. Why? Because this will help us to get the odd value, right? To get odd value, right? To get odd value, what we have to do is we have to place 1 at the end. 1 at the end, right? Now to get the max value, what we have to do? To get the max value, what we have to do? Place all ones except 1 at the leftmost part. Okay. So in order to achieve the maximum value, what we are doing, we are placing all the ones to the leftmost part. And why we have written except 1? Because this particular one, what we are going to do, we are going to place it at the end, right? So if we have, say, if we have x number of ones, then we are going to place 1 at the end, and here it would be all 0 0 0 0, and then what we are going to have, we are going to have 1 1 1 1 1, and this would be x minus 1 ones, right? If we have x number of 1, then we will place 1 over here at the end, and x minus 1 ones towards the left, and rest all these places would be filled with zeros. Fine. Then only we'll be able to achieve the maximum odd number. So now let's see how can we solve this problem. So we will start on by taking a variable. Let's say the variable name is 1count. And what this 1count represent? This 1count represents the number of 1 that we have in the given string. Fine. So what we will do is we will iterate over this s to find out the count of 1. So here you can clearly see that we have 3 ones, right? So our 1 count would be 3. After that, what we will do is we will take an empty string as answer. So this answer represents our resultant answer, that is the maximum odd binary number. Okay. So initially it would be an empty string. Now what we have to do is, here what we said is place all the ones except 1 to the leftmost part. Okay. So here how many ones we are having? 3 ones. So 1 we will reserve it for the last place. Okay. And rest ones we will add at the front. So what we will do? We will, since we have total of 3 ones, so what we will do? We will keep 1 for the end. So it means we are left with how many ones? We are left with 2 ones. So what we will do? We will add it to the leftmost. So we will add 2 ones to answer. So our answer would become 1 1. Fine. Now we have added 2 ones. So our 1 count will decrement to 1. Fine. After that, what we will do? We have to now add these zeros. And how many zeros do we have? Length of the string is 5, and out of this 5 we have 3 ones. So it means how many zeros do we have? It means that we have 5 minus 3 number of zeros, which is nothing but 2. Now we have to add 0 2 times to this answer. So what we will get? We will get 1 1 0 0. Fine. And at last, what we have to do is we have to add this 1 at the end. So what we will get is 1 1 0 0 1. So this is our final answer. And what is the decimal value corresponding to it? So it would be, let's see, we'll have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So this would be 1, 2, 4, 8, 16. We have 1 0 0 1 1. So we have to multiply this 1 with 16, we'll get a 16. 1 with 8, we'll get a 8. 0 into 4 would be 0. 0 into 2 would be 0. 1 into 1 is 1. And we have to add these. So we'll get 25. Correct? So if we are given this string, then this is the answer. I mean, this is the answer which represents the maximum odd binary number. Okay. Now let's quickly code this. So we'll start on by taking a variable 1count, which would be initially 0. So we will be using this variable to find out the count of 1 in the given string. So we will iterate over the string, and we will say that if current is equal to 1, then what we'll do? We will increment the count of 1. Fine. Now, once we have found out the count of 1, what we have to do is we have to place all the ones except 1 to the leftmost part, right? So let's take a string first as answer, which would be initially empty. Now, what we have to do is place 1count minus 1 number of ones at the left. So we will say that I is equal to 0, I is then 1 count minus 1, I plus plus. What we have to do? We have to add 1 to our answer. Now, once we have added 1count minus 1 number of ones, what we are supposed to do is we were supposed to place the remaining zeros, right? So what is the number of remaining zero? So let's say we have zero count over here. So what would be zero count? It would be nothing but the size of the given string minus the count once, right? So this would be our zero count. So what we'll do is I equal to 0, I less than zero count, I plus plus. What we will do? We will add 0 to our answer. Now once we have added all the remaining 0, what we have to do is we have to place 1 1 at the end, right? So we will add 1 1 at the end. What we are doing is place 1 1 at the end. Fine. And after that, what we have to do is we have to return the answer. So now let's run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Talking about the time complexity and the space complexity. So if the size of the given binary string is n, then the time complexity would be order of n. Why? Because here you can clearly see that we are iterating over the complete string s, right? So the time complexity which this is taking is order of n over here. So we are iterating over the complete string to find out the count of 1. So it is costing us a time complexity of order of n, right? And the space complexity would be order of n as well. Why? Because we have taken a string answer, and at the end it will have a length same as the length of the given string. So that's all about today's daily LeetCode challenge. Thank you.